3A1 Indices. In this part of the lesson, you will learn on multiplication and division of indices, the negative index, and the zero index. Now let's begin. First skill, multiplication and division of indices. Now simplify the following, leaving your answer in positive index form. Now the question says positive index form, so our power, the index form itself, is supposed to be positive. Now let's take a look at the first question. We have 15a times a times a times a. So this number over here is 15. Multiplied to 1/3 b times b. So this is all multiplication. It's actually 15 times 1/3. We can evaluate the numbers first. So this is 15 times 1/3, which gives us the number 5. Right? And then now we'll look at our indices for our algebra. So this is a times a times a. So it's actually a to the power of 1, 2, 3, 4, a to the power of 4. Multiplied to b times b, so this is actually b to the power of 2b squared. Okay, this should be the final answer. Now, common mistakes is that some of the students, they will write the answer as 5a to the power of 4 times b to the power of 2. Notice that this multiplication sign over here is not necessary. So if you give this answer, this is actually the non-simplified form. The question did say to simplify, so we must give it in the simplest possible form. Okay, so this one will be your final answer. Let's move on to question B. Now question B, what's inside question B? First, we have 3 times m squared times 2 times m 3 times, and then times d another 2 times. Firstly, let us handle the numbers first. We have 3 multiply with 2. So we can deal with the numbers, the calculation first. 3 times 2 is the number 6. Then what does the next one means? We have m squared, and we have m. So this one over here, this actually means m times m. And this one, I have another 3 more. 1, 2, 3. So in total, I will have 1, 2, 3, 4, 5. 2 with another 3 more. So this one will become m to the power of 5. Okay, and next one we have d times d, so this one will give you d squared. Alright, so leaving answer in the simplest possible form, this will be the correct answer. Next question, how do we do division? Right, when I have something over here, this is 8, a times a times a, b, divided by 2, a times a, b times b times b times b. So in this case, what usually I will do is I'll convert it into a fraction first. So the numerator is still 8. Now let's try to simplify a little bit. This one has a times a times a 3 times. So it's a to the power of 3. And this is b on top of here. Right? Over divided by the whole of, so this is 2 and everything, so this is 2. A times a gives you a squared, b to the power of 3. Then now let's deal with the numbers one at a time. This is not the final answer yet. Okay, let's deal with the numbers one at a time first. So the first one, 8 divided by 2, what do we get? 8 divided by 2 is the number 4. Next one, a cubed and a squared. A times a and a. What can we do? We can cancel out the common factors. So cancel out left 1, cancel out left 1, and then we are left with a to the power of 1 in the numerator. So at the top. So this is a to the power of 1. Now a to the power 1, the 1 is actually invisible. We do not need to write the power. Next one, b. Let's look at the letter b. This is b over b cubed. B cubed is actually this. So what do we get? We try to cancel out the common factor. We're left with 1. So we are left with b times b, which is actually b squared, but it's in the denominator. So we'll put b squared over here. So this will be your final answer. Okay? Have you gotten the concept? Now let's move on to the next part where we are looking at negative indices. Now most of the question over here will tell us to simplify the answer and leaving our answer in positive index notation. So what does a negative index form means? For example, if I were to give you x to the power of -1, what does this actually mean? It means we need to change the x into 1 over. Right, so when I have a negative power, the negative effect is actually changing the letter into 1 over, taking the reciprocal 1 over. Okay, so in this case, this is x to the power of 1, so it's just 1 over x. By right, it should be x to the power of 1, but since 1 is invisible, so the final answer will just be 1 over x. So when you see a negative power, you know something needs to shift. In this case, x is just a number on its own. I'll add 1 over. It become from numerator to the denominator. Right? Next. Look at the next question. This is 3b to power of -2. Notice there's a power -2 here. And this power -2 is for which one? Is it for the number 3 or is it for the letter b? Or is it for the whole of 3b? Well, this power -2 is only for b. So that means in this case, 3 is left alone, untouched. So I will need to have a fraction. 3 stays untouched, it stays in the numerator. But now b changes to 1 over b squared. 1 over. So b changed from the numerator down to the denominator, where it's now b. But this is square, so now it becomes b to the power +2. Okay, so this is the answer. Now, common mistake, students will write this as the answer. Now, this over here is wrong because the moment you have shifted the b to the denominator, make it 1 over b squared already, there will be no more negative power. So this one is actually wrong over here. Right, there'll be no more negative power. So for this type of question, it's very commonly tested in common tests or N-level exams. So please remember, this power -2 is only for the letter b in this case. So 3 stays in the numerator, doesn't move, but b changes now to the denominator. Okay. Now, so far we have learned just numbers on their own and they have changed to fractions in the denominator. What happens if I have a fraction itself? So for example, if I have h over 5 whole thing to the power of -1, what does this mean? This means that both the h and the 5 need to change the position. They need to be switch a different position. So in my fraction, from h, where it is in the numerator, it will now change to the denominator, to the power of 1. So power 1 is invisible, we don't write the power. And 5, from the denominator now, it will now switch up to the numerator. And this is 5 to the power of 1, so we do not need to write the number. The power 1. So technically speaking, when I have a fraction whole thing to the power of a negative power, I will need to flip my fraction. Okay, need to flip this whole thing over, right, into 5 over h. So this will be the final answer. Let's try one more question over here. What happens now if I did not tell you it's holding to power of -1, but they have different powers on their own, but they are all negative power? Alright, what does this mean? So in my original fraction, this means that whatever that has the negative power will need to change position, need to shift, right? So x has the power -2. It was in the numerator, and now it changes to x to the power of 2 in the denominator. And take note, this power over here is +2. Right? So x shifted to the denominator. And for what about y? Y will need to, this is y to power negative 3. So this power y here will need to switch up to the numerator, y. And now it will change to power, positive power. So y to the power of 3. And this will be the final answer. Okay, so take note of the negative power. It will shift the power. If you want to change it to the positive index form, you shift the letter to a different position. What if I have a question that looks like that? If my negative power is only for one of the letters, let's say in the denominator. So now this power is negative 2. This power negative 2 is for which one? Is it for 5? Is it for B? Or is it for the whole of 5B? So in this case, this power negative 2 is only for the letter B. So what do we do? In my fraction over here, a cube has no negative power. So it stays as a cube. And 5 has no negative power. So 5 stays in the denominator. Did not move anywhere. But B now has a negative power too. So only B itself will switch the position to be in the numerator, which is B. But now we have changed it to the positive index form. So it's no longer negative 2. It will be B to the power of positive 2. So this will be the answer. Alright, so in this case, only B has the negative power, so only B will shift the position. Alright, next one. What happens if, in this case, my letter G has the one with the negative power and it is in the numerator? So in this case, you can observe this power negative 3. This is for, is it for 2? Or is it for G? Or is it for the 2G? Well, this is for G only. So in this case, the number 2 has no negative power. It stays in the numerator. F has no negative power. It stays in the denominator. So G, what will happen to G? G to the power of negative 3 will now need to shift place. It will become G to the power of positive 3. So the moment we have shifted it, that will change to a positive index form, positive power. So what we have just done, we have changed all those with the negative power into the positive index form. So into all positive power over here. Right? Have you gotten the concept? Now let's move on to the last part on zero index. What's a zero index? Now zero index rule tells me that anything, okay, to the power of 0 will always become the number 1. Anything to the power of 0 will always become the number 1. So usually this type of question will ask us to evaluate. What does the word evaluate means? Evaluate means to find the value. To find the value of. So I need to find the final answer using my calculator or using my calculations. So now what does 5 to the power of 0 changes to? Anything to the power of 0 is 1. So 5 to the power of 0 will also be 1. So now this one will be 1 plus 10 and it gives me the number 11. Please show your working to indicate that you understand this concept over here, that 5 to the power of 0 is now 1. Okay? Next one, what about this? 5 times p to the power of 0 minus 2. This power 0 over here is for which number? Which one? Is it for the number 5? Or is it just for p? Or is it for the whole of 5p? Well, this power 0 is for the letter p only. So this is different from 5p to the power of 0. There's a bracket, right? So this one over here will be equals to 1, but this one over here, the 0 is only for the letter P, so only the letter P becomes the number 1. So now this is actually 5 times number 1. So P to power 0 has changed to number 1 minus 2. 5 times 1 is actually 5, so 5 minus 2 gives you the number 3. Alright. Okay, so please check, this power is only for the letter P, not for the whole thing. Right. Next question. What happens if we have something that looks like that? 5 to power negative 1 plus 3p to power of 0. So what is this? 5 to power of negative 1. So what is the effect of negative power? It would change my 5 to the fraction 1 over 5. Now this one is just 5 to the power of 1. So 1 is, I do not need to write the 1, it's invisible. So it's just 1 over 5. If there are questions such as 1 over 5 to the power of negative 2, right? That will become 1 over 5 square. Then we cannot leave the answer in this case because the question asks us to evaluate. We'll need to change it to 1 over 25. 5 square is 5 times 5, which is 25. Or you can simply key 5 to power negative 2 inside your calculator. Same thing over here, you can also simply key 5 to power of negative 1 into your calculator and you'll get 1 over 5. Okay. Plus our next portion, this is 3p whole thing to the power of 0. So this power of 0 is for the whole thing itself. It's not just only for the letter P. So in this case, anything to the power of 0, the whole thing would change to the number 1. Now, a lot of students will leave this as the final answer. No, this is not correct. Simplify it in either mixed number or improper fraction. So this is 1 and 1 over 5. This will be the answer. Okay, alternatively, when you have such questions that you can be calculated using your calculator where everything is just numbers, you can use your calculator to help you to find the final answer. Alright, so in summary, when we have multiplication, right, we need to simplify the numbers first, and then we check how many powers are there in total. Right, if we have division, it will be slightly longer. We need to simplify which one is the numerator, which one is in the denominator, calculate the numbers first, and then evaluate the letter by letter. If I have a negative index form, I'll need to change it to a positive index form. Then I need to observe that the negative power is for which letter or number, or is it for the whole thing, before I shift the position. And last but not least, anything to the power of 0 will always be equals to 1. And we will use such answers to help us evaluate and find the numerical values of certain expression. Alright, now if you have understood all this, then we'll be end of this part of the lesson. We'll see you for the next lesson. Goodbye.